Introduction to questions 4 to 7. A graph may represent more than one transformation of the graph of the parent function. The order in which multiple transformations are performed is determined by the order of operations as indicated in the equation. Number 4. How is the graph of f of x equals x squared transformed to produce the graph of g of x equals 2x squared minus 5? Well, what's happening to x squared? First thing is it's being multiplied by 2, right? So if you recall to yesterday's lesson, if a is greater than 1, it is going to be a stretch vertically of a factor of 2. So the first thing we're going to do is we're going to say stretch vertically by a factor of 2. Then we subtract 5. Now notice that 5's location is not in parentheses. So what this does is this translates the graph down 5 units. Use the transformations you described in item 4 to graph the function g of x equals 2x squared minus 5. So, remember we had those most common ones. We had 4, 1, 0, 1, 4. Well, what this says is we're going to multiply by 2, so that's going to be 8. Then we're going to subtract 5, so that's going to be 3. Here we're going to multiply by 2, so that's going to be 2 minus 5 is negative 4. Here we're going to multiply by 2, that's going to be 0 minus 5 is negative 5. Here we're going to multiply by 2, subtract 5, that's going to make that negative 4. Multiply by 2, subtract 5 is going to make that 3. So we have a point. Remember that this was negative 2, negative 1, 0, 1, and 2. So we have a point at negative 2, comma 3. We have a point at negative 1, comma negative 4. We have a point at 0, comma negative 5, 1, comma 5, negative 4, sorry, and 2, comma positive 3. So we stretched it vertically, and then we shifted it down 5 units. How would you transform the graph of f of x equals x squared to produce the graph of the function negative 1/2 x squared plus 4? Well, first, we're going to shrink it vertically by a factor of 1/2 and reflect it over the x-axis. So we've got a reflection over the x-axis, followed by a vertical shrink of a factor of 1/2. Lastly, shifted up 4 units. Okay, use the transformation you described in item 6 to graph the function -1/2 x squared plus 4. Identify the vertex and axis of symmetry of the parabola. Okay, now remember it's -2, -1, 0, 1, 2. And our main function would be 4, 1, 0, 1, 4. Here we're going to multiply by a -1/2 and then add 4. Well, half of that is 2. Negative would be -2. Plus 4 is +2. So this ordered pair would be -2, 2. Okay? We're going to have 1 times -1/2 is -1/2. Plus 4 is 3.5. So this would be -1, 3.5. -1/2 times 0 is going to be 0, and 0 plus 4 is 4. So it's going to be 0, 4. We've got 1 times -1/2 is -1/2. Plus 4 is 3.5. So this is going to be 1, 3.5. Lastly, we have 4 times -1/2, so that's -2. Plus 4 is 2. So this ordered pair is 2, 2. So we have -2, 2, -1, 3.5, 0, 4, 1, 3.5, and 2, 2. So we flipped it. It's a reflection. We shrunk it by 1/2 vertically, and then we shifted it up 4 units. It says identify the vertex. Vertex is going to be at 0, 4. Axis of symmetry is going to be, I didn't mean to put parentheses there, x equals, folds right along that y-axis, which is x equals 0. Go ahead and take a moment to write down your answers to questions 4 through 7. On the next slide, you will see a debriefing question.